Bob. And Bob, I really appreciate all of your patience. We've been trying to set up this presentation for quite a while, so it's nice to finally be here. And I welcome you all this evening. I'm Eileen Everett. I own a business called Down to Earth Education. I'll tell you a little bit more about my background. My goals for this evening are to give you a brief introduction to the science of climate change and some of the current information that exists out there with an emphasis on specifically what's happening here in New Mexico. And mostly I'm going to be focused on how to communicate about this topic. That's been most of my work focused in this area has been how do we actually communicate about this topic of global warming and climate change to the public. So most of the information I'm going to be presenting tonight is how I would present this information to the general public. So maybe some information that you've already heard before, but again, I'm going to be kind of giving you some tricks of the trade of how to actually communicate this information to your classmates and to other people in the community. And a little bit about who I am. I'm actually trained as a wildlife biologist. I have a master's of science in wildlife science. So I spent the first part of my career chasing after critters that fly and slither around and swim. And partway through my career being a wildlife biologist, I realized that there was a real need for education and outreach, specifically environmental education. So back in 2004, I moved to the Audubon Center here in Santa Fe, and I headed up Audubon, New Mexico, the education department, for a little over 4 years. And then back in 2008, I went into business for myself under Down to Earth Education. And through that work, I actually was hired to develop the climate change education programming at the New Mexico Museum of Natural History and Science. And for the last few months, I've been very fortunate to be back in Santa Fe working for the Santa Fe Watershed Association. So that's a little bit about who I am. And if we can go to the next slide, please. So again, one of the things that we're going to be really focused on tonight is the science of climate change. And one of the things that I very much focus on whenever I'm talking about this topic is trying to take the politics and the emotions and the opinions out of this and really just focus on the science. Next, please. And thinking about this topic, whenever I'm communicating about climate change, I always try to think about what's the big picture and what's the story I'm trying to tell. And this slide really tells the story that I'm trying to tell, which is that the sun is our main source of energy and light, and that energy from the sun comes down to our planet. Some of that energy gets absorbed by our planet, and some of that energy gets bounced off of our planet. And then some of that energy gets trapped by this layer of greenhouse gases that occur naturally. And today we see some man-made greenhouse gases contributing to that. And some of that energy gets trapped in here. And the more energy and the more heat that gets trapped by this layer of greenhouse gases, the more changes we see to our climate, specifically an increase in mean global or average global temperature. So I wanted to ask all of you, first of all, what's the difference between climate change and global warming, and is there a difference?
I'm sorry.
No, you can raise your hand. Any guesses? Are they the same thing? Are you guys sick of school, of sitting in class all day and answering questions? Because I'm going to make you guys answer questions tonight, so you better get ready. Yeah?
Well, climate change could refer to any change in weather patterns around the Earth that are caused by, especially we're interested in the ones that are caused by man. It doesn't necessarily mean warming in every place. Global warming is specifically places that are getting hotter, but there are also places that are not. But they're also experiencing climate change.
Any other thoughts? Anybody want to add to that? Generally, when we're talking about global warming versus climate change, when we refer to global warming, we're referring to a temperature change. So if we take a look at our planet, our wonderful planet Earth, over the last 130 years or so, we've seen an increase in average global temperature. So if we look at all the temperatures measured across the surface of our Earth, either on the land or in the air or in the oceans or other bodies of water, we can see that there's an average increase in temperature over that time period. Now that's not to say that there aren't some parts of the planet that have cooled during that time, and there are some parts of our planet that the temperature has stayed relatively the same, but overall we've seen an increase in this average temperature across our planet. Now climate change is referring not just to temperature, but other things related to climate. Things like precipitation, which we're very concerned about here in the Southwest, and things like wind patterns and humidity and barometric pressure, those other pieces that make up part of our climate. So I'm going to want to do a quick demo, and I'm going to need a couple volunteers. I don't have to call on you guys. Can we have any brave volunteers? Oh, I'm going to have to call on you guys then. Okay, can I have you come up first, please? And you are going to be Earth, the wonderful planet Earth. And let's see, I'm going to have this lovely gentleman. All right, let's have our sun come on over here, please. So again, just a quick demo that we have our sun. These are not to scale. Okay, our sun would be much, much bigger, and it would be way, way outside the building if we really showed the proportional distance. But we have the sun, which is our main source of energy. It comes down to our planet Earth, and again, some of that energy gets absorbed by our planet, and some of that energy gets bounced off the surface of our planet, and we have this layer of greenhouse gases that exist. And this layer of greenhouse gases traps some of that energy and heat close to the surface of our planet. And the more greenhouse gases that we have, the hotter our planet will get. All right, thank you guys. You can just leave those props up there. Thank you. Thank you. Can I have the next slide, please? Okay, so what I want to do is focus on some of the arguments that I've actually heard working at the New Mexico Museum of Natural History and Science. So these are actual comments that I've heard by people who come up, and especially whenever you have the title of climate change communicator or climate change educator, people always like to come up to you and tell you why global warming or climate change is not happening. So these are actual real arguments that I've heard, and this is one of my favorites and one of the most common, which is it was cold, sunny, windy, hot, rainy, dry, balmy, breezy, snowy, fill in whatever weather-related adjective you'd like to hear last week. And that proves there is no such thing as global warming or climate change. Next slide, please. So I want to ask all of you, in terms of temperature, looking back towards last winter here in Santa Fe, what was the temperature like compared to average? Were we A, above average, B, warmer than average, or C, cooler than average? How many people think that we were about average A? Raise your hand. Okay, we have some folks guessing about average. How many people think B, we were warmer than average? Raise your hand. We have some folks thinking warmer. How about C, cooler than average? Okay, that's the most common guess that we get when we ask that question. Most people think we had very cold temperatures because we did. We had some record lows. If you think back in February last year, we had those extremely cold temperatures, and some of you maybe even got out of school for a few days that week, maybe even the whole week, because we had that extreme cold that came through. But if we average out all of the temperatures throughout the whole season last winter, we were actually still above average in terms of temperature. And most people think that we were below average, again, because we had that cold snap, which impacted a lot of our lives. There were people here in northern New Mexico who ran out of natural gas. Schools closed. We saw this happening on a daily basis. It was in the news. So we have this perception that it was much cooler than average, even though when we look at the average of all of the temperatures over the whole winter last year, we were above average. Next slide, please. So this leads us into a conversation about climate versus weather. Climate is long-term and weather is short-term. We can predict the weather over the next 7 to 10 days fairly accurately, but again, it's over the short term. When we talk about climate, we're talking about annual cycles. We're looking at cycles over decades, centuries, millennium, very long time periods. And again, when we're looking at climate, we don't just look at temperature, but we look at precipitation, atmospheric pressure, humidity, wind patterns, wind speed, wind direction. All these different pieces go into climate. And a middle schooler put it best to help us remember the difference between weather and climate, that climate tells you what clothes to buy, and weather tells you what clothes to wear today. Next slide, please. Any questions so far? No questions. Okay. Argument number 2. This is becoming less and less common that I've seen this argument, but we cannot measure past climate. So how can we say that our climate is changing today if we can't look back at the climate of the past? Next slide, please. We can measure the climate of the past, and there's 2 main ways that we can actually look back at past climate. The first is looking at direct measures of climate. Now, direct measure of climate would be if any of us took a thermometer, we put it out in our backyard, and recorded the temperature at the same time every day for the rest of our lives. That's a direct measure of climate. We can only do that going back about 130 years or so because we didn't have that kind of technology that went further back than that. So if we want to go back further than 130 years, we have to use what we call indirect measures of climate. Indirect measures of climate use these things called proxies, which I'm going to describe some of these in just a moment, to measure all different aspects of our climate systems. And they can measure things like temperature of the past, precipitation of the past, the amount of greenhouse gases that actually existed in the atmosphere in the past. And these proxies can go back anywhere from hundreds of years in time to millions of years in time. And scientists tend to really focus on one type of proxy, but when they're studying that one type of proxy, they compare that proxy with other proxies around the world to see if that information matches up and to see if they're getting similar climate information. Next slide, please. So here are some examples from around the world of how scientists collect information about past climates. So one of the most common ways that we hear is looking at ice core sampling. And it's a really great way to look at temperature change and precipitation change. And the really fun thing about ice core sampling, either in the Arctic or in the Antarctic or in glaciers around the world, is that air bubbles have been trapped in different layers in the ice. And within those air bubbles, we can actually measure the concentration of greenhouse gases that occurred in the atmosphere during different periods of time. You can also look at lake sediment cores, which is pulling cores of mud out from the bottom of lakes. You can actually look back at climate going back hundreds of millions of years in time. We talk here, specifically here in the Southwest, about dendrochronology, or studying tree rings. This is a great way. Every year, most trees put on one growth ring. Depending upon the thickness of that ring, we can tell if it was a good year for that tree to grow, if it was a good temperature and good precipitation, or if it wasn't. It's also a good way to look at fire history here in the Southwest. You can also look at coral in the oceans, and coral actually puts on annual growth rings as well, and can provide us information about our ocean systems. Pack rat middens are one of the coolest things that scientists are studying. Okay. Has anybody here ever had to deal with a pack rat problem? Okay. They are a pain to deal with. Okay. Pack rats will take anything they can find. They love shiny things, especially keys. Okay, so don't ever leave your keys out. Because of the pack rat, they like to take them. And pack rats, they collect all of these things, and they like to collect actually a lot of vegetation, little pieces of plants. And they take them and they put them in what's called a pack rat midden, and then they pee all over it. That's what they do. They pee and they poop all over it. And that pee and poop, the pack rat pee and poop, actually preserves all that stuff that they just collected in their pack rat midden. Okay? So who would have thought that we would have learned about past climate from pack rat urine? Very interesting thing. This has actually been looked at a lot here in the Southwest. And you can go back up to, actually you can go back over 20,000 years in time, looking at pack rat midden information. Also here in the Southwest, we can look to caves for some of this information. Stalagmites can actually show us, not on the scale that things like lake sediment cores or even ice cores can, but you can go back tens of thousands of years of time looking at stalagmites. Does anybody have any questions about studying any of these proxies or looking at past climates? Yeah.
One of the premises you put forth is that the time scale is the thing that separates weather from climate.
Yes.
And so you get into cycles where, the quote mini ice age of the late 1600s, 1700s. So how do you use for your work time scale? What time scale are you looking at?
It really depends upon what I'm looking at. Generally, when I present graphs to the public, I'll go back about 1,000 years in time. Main story that we're trying to really look at today is the past 100 years in time. Main story that we're trying to really look at today is the past 130 years. But again, to give that perspective, I'll typically go 1,000 years. But you can see graphs that exist, especially if you look on the internet, that go back hundreds of thousands, even now millions of years in time.
How does the pack rat middens, how do you analyze them to know what shape they are?
You can actually do carbon dating on them. to figure out, especially for the pieces of plants and vegetation that exist in there. Any other questions?
So what are you actually looking at then when you study the pack rat middens?
So the main thing that the researchers are looking at with the pack rat middens is what type of vegetation occurred in that area. Again, since they actually clip that vegetation, it's also preserved in their feces as well. It gives you a good idea of what plants occurred on the landscape, and then those plants can kind of tell you what the climate was like in that area. Yes?
Is one type of study more accurate than another and correlate them all?
That's a really good question. I can't speak if there's one in particular that's kind of the go-to, the best. So the question was, is there one type of area here, one type of particular focus that researchers think is maybe more accurate for studying past climate? And my answer is that I don't know of anyone that's necessarily more accurate, but one thing that researchers do, if you're a researcher in the Southwest studying a pack rat midden, you're in conversation with someone in Antarctica who's studying that same time period, looking at ice core samples to see if that climate information matches up. So a lot of the information that we see, especially when you see these graphs that show temperature change over time and even carbon dioxide change over time, they're not necessarily looking just at one of these, but they're taking into account information from all of these.
With the background stuff, is that done by carbon dating to assess when the time period was?
Yes, yes. And they've gone back a little over 20,000 years so far. Yes.
Eileen, particularly stalagmites as compared to stalactites.
So stalagmites, just because the water is dripping down and they're growing, and for some reason they prefer to study the stalagmites. They also study stalactites as well, but most of the research is actually focused on stalagmites. Next slide, please. This is becoming one of my favorites, and it's becoming very, very, very common, which is, it's the sun. It's that darn sun. We need to blame the sun. It's the sun causing all of the warming. Or more commonly here, it's sunspots causing the warming. We have the next slide, please. There's a lot of different ways to address this. Sunspot cycles typically occur over 11-year cycles. Again, if we look back at 130 years of time and looking at temperature, we can see that there's still been an increase even across those 11-year cycles. This is one slide that I sometimes use to address the sunspot or sun response. And this is showing two different layers of our atmosphere. This is looking at information from the troposphere, which is the lower part of our atmosphere, and the stratosphere, which is higher up in our atmosphere. The troposphere is where most of human activity occurs. It's where things like weather occur. And this is information that's actually from the National Oceanic and Atmospheric Administration, known as NOAA. They're the ones that provide us the National Weather Service. And NOAA collected this information from the mid-1970s through the mid-2000s. And this is showing temperature change over that 30-year time frame. If the sun and sunspots were the thing that was causing all or most of the warming that we're seeing today, we could expect that we would see a similar warming throughout all layers of our atmosphere. Since the sun is way outside of our atmosphere, we would expect if the sun was causing all of this warming, that it would be warming up all the layers of our atmosphere at relatively the same rate. When we actually look at the data, and this is data actually collected from satellites, we can see that that's not the case. If we look at our lower atmosphere at this troposphere level, we can see that there's a lot of oranges and yellows and some reds showing an increase in temperature over that 30-year time frame. And if we look higher up in the stratosphere, we can actually see that there was a cooling during that same time period. So if the sun was the only thing causing this increase in warming that we're seeing today, we would expect to see a similar story in the stratosphere occurring as to what we see going on in the troposphere. Does anybody know what this spot is in the stratosphere? Any guesses? This is the ozone hole, okay? Ozone is a greenhouse gas when it's in the lower troposphere, but it acts differently in the stratosphere. The ozone hole became a particular concern in the 1980s. And the ozone hole is a really interesting story to share because consumers actually started making a big difference and not buying products that release CFCs into the atmosphere that were causing this ozone hole before the regulations actually went into place. So American consumers actually made a big difference before the government actually stepped in and started regulating those. So, yes?
So did it occur also globally?
There were other countries doing similar things at the same time. I know mostly here in the U.S., though, there was action already taken by consumers before the laws were
And it
passed.
was significant to the...
It was significant to start reducing the impacts. Now, we can still see evidence of the ozone hole today, so it's something that's going to take a long time period to see the reversal of that. But we've slowed down the impacts of that
So it
beginning in
can
the
recover.
1980s. Over time, yes. Longer time scales.
It seems that there's a correlation in the troposphere of the hotter areas with the colder areas in the stratosphere. So there's a big variation of temperature in those in some places.
There is a big variation in temperature. And again, going back when we're talking about that global warming, that increase in average temperature, especially looking at the troposphere, it's a good way to look at. You can see that there are some areas, especially in the Arctic and around Greenland, that we've seen a big increase in temperature. And some areas of our planet down here by the Antarctic that you've seen this cooling. I can't speak to specific regions, though, that the correlations between if there's warming down in the troposphere and cooling going on in the stratosphere, for example. Any other questions or comments? Could we have the next slide, please? Oh, can we go back one? So I use this slide to demonstrate how scientists have pieced this picture together and put together this story of the climate change that we're seeing today. So I'm going to start here at the bottom, which is looking at temperature change over time. We see, it's a little bit hard to see probably in the back, but there's this purple line that is using indirect measures of climate to measure temperature going back about 1,000 years. We can see that there is variability within that. Okay? We don't ever expect that the temperature is always going to be the same. We're always going to see this variability. One thing we're always going to see variability, and a lot of variability of here in New Mexico, is precipitation in particular. There's some areas that we get a lot of precipitation, some years that we get very little precipitation, and some that's in the middle. But precipitation, particularly here in the Southwest, we see a lot of variability. But temperature over longer periods of time, we're always going to see this variability. And this kind of dark-colored green-black line is using direct measures of climate, measuring temperature the last 130 years or so. So we can see even with this variability, we've seen an increase in temperature about 0.7 degrees Celsius over the last 130 years. And I'd like to point out up here this same graph over the same time scale, about 1,000 years, looking at the population of our planet. If we look at the population of our planet over the last 130 years or so, we've actually seen our population double and then double again. So we've seen a lot more humans on our planet. And in the same time period, we had the Industrial Revolution, which affected all of our lives even today, which allowed us to have things like electricity and vehicles and most of the things that we all need and depend upon today. And as population increased and after the Industrial Revolution happened, we started to see that greenhouse gases like carbon dioxide, which is the one that we hear about the most, and even things like nitrous oxide and methane began increasing during these same time periods. So one thing that scientists look for is trends, and this is a really nice picture to kind of show how these trends all look similar between these different graphs too. That link between population and more humans on the planet, humans releasing more greenhouse gases by the actions that we're doing, and also this increase in temperature and other changes to our climate as well.
Do you have any references that show that on a per capita basis?
On a per capita basis?
Basically, normalizing, dividing the carbon dioxide, nitrous oxide, and methane by the population as a per person.
As a per person, I don't have that information today. Yeah, we're just looking at it from a global perspective. Next slide, please. So this is also another common argument that I hear is it's just part of the natural cycle, and humans can't have that much of an impact on a global system like our climate. Next slide, please. So again, going back to greenhouse gases, we have a variety of greenhouse gases that exist in our lower atmosphere. Water vapor is actually the most prevalent greenhouse gas that we have that exists. And the interesting story with water vapor is that as temperature increases, you have an increase in the concentration of water vapor, which then you see an increase in temperature, and then you see an increase in water vapor. And it's what we call a positive feedback loop, that they feed into one another. But again, water vapor is our most prevalent greenhouse gas that we have. The one that we hear about most in the news especially is carbon dioxide, but methane and ozone in the lower atmosphere acts as a greenhouse gas, and nitrous oxide does as well. Greenhouse gases are an important part of our planet. We need them to survive. If we didn't have greenhouse gases and the greenhouse effect, the average surface temperature of our planet would be about 60 degrees Fahrenheit. It would be so much cooler that most of our oceans would freeze. That's how much colder our planet would be. So we need the greenhouse effect to survive. But what we're seeing today is we're seeing an increase in that greenhouse effect, which is causing our planet to warm up, and we're seeing other impacts to our climate as well. Next slide, please. There's a lot of modeling going on around climate, and we're actually very fortunate here in New Mexico that Sandia National Laboratory and Los Alamos National Laboratory are really on the forefront of doing a lot of the climate modeling. So we're very fortunate to have these minds in New Mexico. And here's just two models that exist, looking a little over 100 years in time. We're going to start here with the top graph. So again, looking at a 100-year time scale. The black line shows actual temperature. This yellow or orange line actually shows a model of that temperature during that same time period. If we take into account both natural sources of greenhouse gases and anthropogenic or human-caused sources of greenhouse gases, if we incorporate both of those pieces into models, we can see that that model generally lines up pretty well with the actual measures of temperature that we've seen over the last 100 years or so. If we look at this bottom graph, again over the same time scale, again the black line showing temperature, this blue line shows just sources of natural greenhouse gases. And if we look at this, we can see that, the model, the blue line, does pretty well with the black actual temperature measurements for the first part of the 20th century. And then we really begin to see this divergence. And again, if we take into account both the natural and human-caused sources of greenhouse gases, that better explains the story of what's going on, particularly with this increase in temperature.
I presume someone's looked at the effect of additional people simply adding extra heat. Is that a negligible effect?
It's a real negligible effect, yes. But people are looking at all different impacts, even things like how much methane cows release and the impact of that. Any other questions? Next slide, please. Again, this is just another graph showing the black lines are annual measurements of temperature, taking into account both land and ocean temperatures across our planet. This red line is a 5-year mean, and the reason we put in a 5-year mean is just to kind of smooth that black line out a little bit. And again, this is just kind of relating back to the last 130 years or so. We've seen this average increase in temperature of about 0.7 degrees Celsius. Next slide, please. This is my favorite, my absolute favorite argument, which is the scientists are not in consensus. Let's just wait a couple years. We'll let them sort out their differences. And then we can begin making some decisions. Do we have any scientists actually in the room tonight? We've got a few. So I'm going to ask the scientists who are in the room tonight, okay? I want you to imagine putting about 500 of your colleagues that are studying similar things to what you're studying in the same room. And I'd like you to come to agreement on anything. Is that an easy thing to do? No. Okay? What's at the heart of the scientific process is disagreeing with one another and questioning. That's really at the heart of what science is you come up with an idea and questioning. That's really at the heart of what science is you come up with an idea, you test that idea, you think you come up with maybe an explanation for that idea, and then you question that idea. That's what scientists do. Can we have the next slide, please? And keep clicking on this. Do maybe 2 more. Keep going, and 1 more. Okay. This is my very unscientific graph. Okay, you students should never, ever, ever do a graph like this because it doesn't have enough information on it. We're going to use this time scale, which I don't have dates on here, but for our time scale tonight, I want you to imagine that this has been the last decade, okay, from about 2001 to today. On the y-axis, we have agreement and human-caused climate change, and as you move up the y-axis, you see an increase in the amount of people who agree with human-caused climate change. The interesting thing of what's happening today is the American public in general is we're seeing this decrease in their agreement with human-caused climate change. And at the same time, you're seeing this increase in the confidence within the scientific community on this subject. If we look back to about 2005, 2006, the polls of the American public show that most of the American public was in agreement that human-caused climate change is real and that there's enough scientific evidence to support that. And we're going to talk a little bit more about the scientific community next. So I've left this blank. So what percentage of climate scientists, so scientists who are actively engaged in studying our climate systems today, think that there is enough scientific evidence to support human-caused climate change?
98.
98. Any other guesses?
97.
100.
100. Again, going back to the heart of science, it's very rare to have 100% agreement. 80%? We had some planted people in the audience tonight, yeah. So, most of the time when I ask this question, most of the American public, I would say, thinks that maybe about half of climate scientists think that there's enough scientific evidence to support human-caused climate change. And the reality is that the recent surveys over the last 3 to 4 years have shown that it's between 97 and 98%. Okay? That's probably going to be the best level of agreement you ever get on this topic and probably any other topic that you can think of in science. Okay? Because that's what scientists do. They disagree all the time. So for 97 to 98% of climate scientists to say that there's enough scientific evidence to support human-caused climate change, that's going to be probably as good as we ever get. I think some of the questions and some of the disagreement that occurs right now in the conversation is what do we do about this now that we have this information, and exactly how much change are we going to see in our climate in the future. Next slide. Just telling us 97%. Next slide, please. So what about the climate of the future? So when we think about disagreement in the scientific community about this topic, this is where most of the disagreement occurs. This is a mess of models, modeling temperature. There's actually about 30 models in this graph, and I could put in this whole legend, but I decided it was even more confusing to do that. Generally, you can see, though, that all the models are in agreement that they show this trend of an increase in temperature, but there's a difference about how much temperature change we're going to see over the next 100 years or so. Generally, the models today are showing 2 to 7 degrees Celsius change by 2100. Next slide, please. Yes?
Why do you think the general public doesn't believe the scientists if there's that much compelling evidence?
I think the main reason is where do people get their information from? They get our information from reading the paper, from listening to the TV, or listening to the radio, watching TV. And a lot of the information that's presented in those sources, it's a much more exciting story to sell controversy than agreement, right? Controversy sells papers. Go read the op-ed page in the paper tonight. Okay, you're not going to see everybody saying, we all agree with everybody else in Santa Fe, because that's never going to sell papers. It's always about disagreement. Okay? And often, particularly with this topic, one of the pieces that frustrates me as someone who wants to communicate about this topic is reading the op-ed page. Because often you'll see articles that are given equal weight. You'll have one article that talks about the science of climate change and that human-caused climate change is happening. And right next to it, you'll see another article that's given the same amount of information, has no science in it, saying that climate change isn't happening. And I think that's one of the biggest hurdles that we face. And we see the same story happen over and over and over again. We can see it looking back at cigarettes and the tobacco industry, information about cigarettes and how that impacts our health, and that cigarettes are linked to lung cancer. There are studies that go all the way back to the 1930s showing that information. But it wasn't until I was a teenager that people really started standing up and saying, you know what, cigarettes are really bad for your health, and you shouldn't smoke them because you can get things like lung cancer and other things. But there was a long period of time, even with the tobacco industry, that the American public doubted this information. And we see the same story go over and over and over. Next slide, please. So what about here in New Mexico? So generally when people say, well, what about where I live here in New Mexico? What is the climate, how is the climate changing today, and how is it going to look in the future? And my answer to that is, if you want to know what the climate of the future is going to look like, look south. Okay? Here in Santa Fe, we can expect that our climate of the future will be more like Albuquerque. The citizens in Albuquerque can expect their climate to look more like El Paso. If you live up in the mountains, look downhill, because that's what your future is going to look like in terms of the climate of the future. If we look here in New Mexico, over 95% of New Mexico has seen an increase in mean temperatures over the last 130 years. The greatest warming in our state has occurred in the central part of the state around Albuquerque, and also in the western part of our state around Gallup. More than 50 of our native species in New Mexico have and are already being impacted by our changing climate. Next slide, please. One of the things about New Mexico is that a lot of things are spaced really far apart in New Mexico. All right? It's one of the things that makes our state very interesting, is that we can go to a lot of different places, see a lot of different landscapes. I can get in my car, I can drive down to Albuquerque, do some different things down in Albuquerque. It's not too far away. And because of that, our greenhouse gas emissions in New Mexico, linked to transportation specifically, are almost twice as high as the average per capita greenhouse gases. Again, this first bullet is specifically related to transportation related greenhouse gases. And over 90% of New Mexico's power-related, so energy-producing greenhouse gases, comes from coal-fired power plants. And so I really encourage you, if you're interested about coal, to come to the Science Cafe next month, because we're going to hear about how to reduce some of these emissions out of coal power plants.
All of these predictions obviously depend on the greenhouse gas production. How did that get taken into account? Was it assumed that greenhouse gases will linearly rise the way they have over the last 10 years or so?
So this is current information today. So just looking at current information today, if we just look at the amount, this is just looking at the information today, so not looking ahead towards how our energy sources might change in the future. So if we just look at electricity, and this is information actually from about 2007, so there might have been a little bit of change between 2007 and now, but most of the energy-related greenhouse gases that are released in our state for our use for electricity are related to coal-fired power plants right now. And there's a lot of ideas and a lot of solutions right now specifically addressing coal and how do we have more clean coal so that we can reduce these greenhouse gas emissions, and how do we look to our other sources of energy to do that as well.
So what if Four Corners was converted to natural gas today? How would that affect us? Is there a
Today, if we didn't update any of the technology, the resources, we'd probably see a decrease. But there's a lot of advances going on. There's a lot of research and development going on right now to look specifically at coal, gas, and oil and how to reduce the impacts of those, along with looking at alternative sources of energy as well. Wind is our most prevalent source of renewable energy that exists in New Mexico right now. So we're also looking at other sources of energy as well.
Do you know how that last statistic relates to nationwide?
Oh, how this relates to nationwide? You know, I don't have that information on the top of my head, but we typically, I will share one thing that's very interesting about New Mexico, which is one source of energy that we don't use very much of here in New Mexico, but that most of the United States uses, is nuclear. PNM owns part of a share in the Palo Verde nuclear plant in Arizona. So kind of indirectly, our company that we pay our electric bills to has a share in that nuclear power plant, but we have no nuclear power plants here in New Mexico currently. If you look at the United States, anywhere from 10 to 11% of the United States on average gets power from nuclear sources.
Well, my mom, she's trying to get out like this, like a Tesla machine thing, and it's like a little box thing, and it has no moving parts, and it like collects gravity, and stuff, and you just plug it in to just get it started for a second, and it just runs forever, but it doesn't have any parts, and it can power like a bunch of stuff, and my mom's trying to get out the into market and stuff.
Very nice. And that's one thing I do want to emphasize, is that there really is a lot of research and development here in New Mexico, but also around the world, to look at all of these different sources of energy. And I'm a big believer, talking about this topic, that we need to be looking at all of these sources of energy and solutions for all of these sources of energy.
I can answer the second to last question.
And that question was related to
how
much greenhouse gas is related to coal emissions.
or how much electricity is generated by coal. And the answer is 52% of all the electricity generated in the United States comes from coal.
So the answer was 52% of all energy produced in the United States is produced by coal sources.
So other than money, what other motivation, I mean, why are they not using a more efficient energy other than money? That's a clear reason.
Money, politics, we all have lots of motivations in our lives. Did I say hand raised?
Well, it's sort of the same question. It's like, how do we force our power companies to use alternative sources?
And I think some of it is, and I'm going to talk about this a little bit more, but as individuals, I think we can all make impacts. But I think moving up the chain, up to looking at our governments, and even to us as humans as a whole society, I think that change needs to come at all levels. But that change has very, very different time frames. We can all make decisions today to change our behavior and how we live our lives. It's a lot different to get change over all across America. Even change within all of New Mexico as well. It's very challenging. Next slide, please. So what about the future of New Mexico? Looking towards 2100, we're expecting here in New Mexico to see an increase on average of 6 to 12 degrees Fahrenheit. And I will tell you that right now, the models that existed when I put this slide up here, when I first created this slide about 2 years ago, the models are actually, all the temperature changes that we've seen over the last couple of years are actually above that trend. So we're actually above what the models are predicting right now. And I'm hoping that we're going to shift back down and not keep seeing the increase in temperature that we're seeing. But right now, the models are showing 6 to 12 degree Fahrenheit change by 2100. And here in New Mexico, we're expected to see an increase in the episodes of extreme heat. If we think back to this summer, we had extreme heat in the summer. And back in 2010, we had our first 100-degree temperature day here in Santa Fe. We're expected to see a decrease in the episodes of extreme cold, an increased duration of the growing season. So those of you who like to grow food at home, you're in luck. That's one of the positive things of a changing climate, because now you have a longer growing season. We're expected to see an increase in intense storm events and more winter precipitation falling as rain rather than snow. These last two bullets are really important bullets to think about, particularly for us here in New Mexico, because one of our scarcest sources that we have here is water. And one of the things that we're expected to see with this changing climate is we're expected to see a big impact on our water supply. Specifically, as in the winter, what normally would fall as snow might fall as rain now. And what does fall as snow will probably melt earlier, and we're going to see an earlier runoff, and it's going to be a lot harder to capture and store that water for our use. So water is one of our biggest concerns in New Mexico for the future. Yes?
Do we have a plan?
That's a good question. I would say that individual municipalities right now are looking at plans. And I can say from my work at the Santa Fe Watershed Association that Santa Fe is right kind of on the forefront of looking at our changing climate and trying to adapt and prepare for that as best we can for the future.
Could you comment on, currently Mexico's considering selling water to San Diego and et cetera, through tapping their resources and also desalination efforts to reduce the impact on the Columbia and the other rivers that occur in California and the rest of us are draining. How does that affect in that desalination is a pretty intensive energy way to generate water?
Desalination is very energy intensive to use that. But in certain parts of the world, it may be the only option right now or in the future. And I think water is going to be one of our biggest issues that particularly we're going to be dealing with in the future. And one of the things that I've gone when talking with high school students or college students is, well, we won't worry about it because we can just take the water from Texas or from these other places. Well, they're not going to be very happy if we go over to these other states and say we want our water. In fact, we have some of those situations going on right now in New Mexico. And we're going to want to hold on to our water and protect our water and store our water as best we can so that we'll have enough for all of us to use. And we don't want other people coming in and taking our water, just as we're probably not going to be able to go out and find water from other states and other places as well. So I think water is going to be one of the biggest issues that the entire western United States is going to be facing in the future. And there's some planning going on for that right now, but probably not enough. Next slide, please. Keep clicking. Oh, so what can I do? So again, as a climate change communicator, I think that change needs to occur at all levels, everywhere from an individual all the way up to us as a society. Next, can you just keep clicking through? One more. So each of these different levels of action has different time scales and different degrees of impact. So I can say today that I'm going to use a reusable water bottle because then I don't have to go and buy plastic bottles that take a lot of energy and a lot of water to manufacture. So I'm going to buy this water bottle for $20, and then I'm going to save money also by not having to buy plastic water bottles at $1 or $2 per bottle if I can reuse this all the time. So I can make that change, and that's not going to save the world, okay? That's going to have a little tiny miniature impact, okay? But I can do that today, okay? I have control over that, and I can make that change today. Hopefully, if all of us do little changes like that, it will have an impact. But I think that impact will need, and action will need to come at all different levels, but trying to have worldwide action on any topic, as we all know, is really, really challenging. And that's one of the things that we're facing today. Any comments or questions? Yes.
Have they isolated the top worldwide action that could occur to improve this process?
You know, my answer to that is that there's no book that exists out there right now that says, here's all the solutions. If you follow this manual, we will save the planet. It doesn't exist. There's a lot of different ideas right now related to all different facets of our lives. In some ways, I think that we're going to have to adapt to a changing climate because our climate's already changed today, and it is changing, and we're adapting to it right now. And I think that we're going to have to change our ways a little bit. And I think that there's a lot of different ideas of how to do that. I'm going to talk a little bit about that. But I don't know of any manual that exists that says, here is the silver bullet of what can be done to change this today. But there's a lot of ideas, and I think we need to be looking at all of these different ideas and implementing as many as possible to make an impact. Next slide, please. And every action does make a difference. So when having people, I know that you hear a lot about, you know, what can I do? How can I reduce my carbon footprint? I'm not going to go into a lot of the specifics of that because we've all heard a lot about that. In a little bit, I'm going to share one activity that I've used to help us think about one part of our lives. But again, one thing that I do as a climate change educator is I look at all different things in my lifestyle that release greenhouse gases. So these different pieces are electricity. How much electricity am I using? What are the sources of energy that are producing that electricity? What can I do to conserve energy and not use as much electricity? Transportation, okay? Transportation is a really big one here in New Mexico. What am I using for transportation? We're actually pretty fortunate here in Santa Fe that we have got a pretty good bus system. Who here has ever ridden the bus system here? Okay. I have ridden buses all over the country and even in other places in the world, and I love our bus system here in Santa Fe. It's really easy. For the most part, it's on time. Okay, there's occasionally times that they're not, but they do a pretty good job, and it's really inexpensive, and you can even put your bike on a bus here. Okay, it's a really great form of transportation. We're really lucky to have that. If we want to go down to Albuquerque, we have things like the rail runner that we can take, other forms of transportation. And there's other motivations that we have for taking these other forms of transportation. If I ride the rail runner, I don't have to pay all that gas. And I have a lot less stress in getting to Albuquerque as well. Looking at our heating and cooling, okay? Do our houses need to be as cool as they are in the summertime? Or they need to be as warm as they are in the wintertime? I love to hike and be outdoors. Who here likes to be outdoors in the winter? Most of you? Okay. I actually think it's better, particularly in the winter, to not keep your houses really warm, because the cooler your house is, the more acclimated you are to be in the outdoors. So particularly if you like sports that involve lots of snow, like skiing and snowboarding, those kinds of things, it's actually better for your body if you keep your house a little bit cooler, because your body's going to be more acclimated for those kinds of activities too. Looking at our consumption, when you're going to purchase a product, do you really need to buy that product? Do you really need that? And where does that object come from? And where are you purchasing it from? And waste. Are you recycling as much as you can? Are you reusing what you can? And again, this is directly linked to our consumption. When you're first buying a product, you even need to buy that product. Next slide, please. So that is it. And I'm going to describe an activity here shortly. But before I describe the activity, does anybody have any questions or comments? No questions or comments. So you guys are all ready to go out into the world and communicate about climate change? Is that what I'm hearing?
Okay, here's one comment.
Okay.
Free the press from corporate control, and the real stories will be reported to the public. And then they will do something about it, because in the ozone layer, that was presented as a public health crisis, not a political thing. And people understood they would get cancer, and they banned fluorocarbons as a result.
Well, and also, I mean, there were easy solutions, alternatives to an aerosol can. So it wasn't such a big deal, because I'm old enough to remember hairspray and so on, and they came up with some solutions pretty quickly, which were probably cheaper, actually. Right?
But the answer to that might be people didn't view it as a conservative liberal issue at the time. It was a general issue. When you have phrases like clean coal, which does not exist as a reality, and you have, say, GE, who owns NBC, it's really difficult today. So I think we all have to work to get the money out of the political conversation, or else we'll never know the truth.
I mean, even NPR has been, I mean, they're advertising the argument.
And I think one of the hardest things about this topic is that even though our climate is changing today, it's hard to see those impacts of that changing climate today, and it doesn't seem so immediate. There's not an immediate consequence, okay? If you guys at school tomorrow stand up in the middle of class and you take your notebook and you throw it across the room, there's going to be consequences, right? Teacher's going to be very mad. You may have to go to the principal's office, okay? Wouldn't be good. There's immediate consequences. The consequences for climate change, even though they're much larger in scale, they're harder to see. And I think that is also one of the challenges that we face right now, is because it's longer term, and people often think about climate change as happening far away, that polar bears are swimming in the ocean because they don't have icebergs. So it's not impacting us, but it is impacting us. But people have a harder time seeing that. And because the consequences are longer term, and maybe outside of our lifetime for some of us, that it's harder sometimes to get people to take action on those kinds of time frames.
But to that point, you talk about global climate change, and people don't relate to that. And really, the place where this is really going to be first felt is in regional changes. So regionally, the impacts will be much greater than this little bit of temperature that's increasing. I mean, I don't think believe in that. And the thing that worries me about the Southwest is the water. So I believe that the way climate change is going to be played out in the Southwest is through the water connection.
Yes.
And that will cause people to act before they say, you know, temperature change of 1 degree globally. Well, okay, what does that mean? But if we have 30% less water here, people are going to be really impacted. So I wonder if that's an angle in your education to really...
It's sometimes, I talk a lot about water, particularly here, because in New Mexico, that's going to be the biggest problem that we're facing in the immediate future. And I think that's just the concern that we need to be focused on, and we don't want to get in situations that we're going to get into water wars with people as well. The other story that I do tell people, especially where since I've been so immersed in this topic and been thinking about it a lot, is that I've actually become way less concerned about our planet. And I've actually become much more concerned about humans. Because I feel like the reality is humans have not been on the planet for a very long time. If you look at the whole life of our planet, we've been here just a blink of the eye, okay? Very short time period. And the reality is that when our climates have changed in the past, humans have either moved, they've adapted, or they've perished. I am most concerned right now about humans perishing in the future. Because the track that we're on right now, if we don't change our ways, I think the planet's going to be fine. You know, the planet has ways of changing and adapting overall. Not to say that we wouldn't lose a lot of species along the way, and I hope that we wouldn't lose humans along the way as well. But I think actually that's become my bigger concern with this topic, is that let's think about humans. If you don't care about the planet or don't want to think about the planet, okay, but think about the impact on future humans.
Is the rate at which the increase is happening changing? In other words, you said 7 degrees, that implies as you know, a gradually increasing thing over time, but are we seeing even, you know, nuances of change, rate change?
So very, very good question. Kind of the leading group that's focused on publishing information about climate change is called the IPCC, which is the International Panel on Climate Change, which has scientists and government officials from all over the world that come together. And back in 2007, they released their 4th report, which is many hundred pages long, okay? And they have actually 4 different reports that they released. And they put models in based upon, and one of the biggest questions is, what are humans going to do? You can predict a little bit about how temperature is going to change related to cloud cover, or how surface air temperature change will relate to warming ocean temperatures. You know, scientists are pretty good at modeling that type of information. But one of the biggest pieces that they're having a hard time modeling is humans, because they don't know what humans are going to do. Are we going to change our ways, or are we going to keep doing business as usual? They don't know. So they've developed different models, and the 4 main models that were produced in the 2007 International Panel on Climate Change report, all of the increase in temperatures that we've seen, we are actually above all of those models today. So we're actually seeing a larger rate of increase than even what was predicted back in 2007. And the International Panel on Climate Change is meeting today, and they're predicted they're going to release their 5th assessment report within the next couple of years.
So a couple of years ago, we had that big 350. Can you explain what that is? And it seemed like that was a tipping point. Are we beyond that? And Al Gore talked about all of that. You know, it's the big point of no return kind of thing.
So when you start getting into this topic of climate change and you start looking at what is the tipping point, there's a lot of different tipping points that are thrown out. One of the main ones that's been focused on the last few years is 350, and there's the 350.org organization that's named the 350. 350 stands for 350 parts per million, which is a concentration of carbon dioxide level in our atmosphere. It came from a scientist called James Hansen, Dr. James Hansen, from NASA. He came up with that number and said if we get above 350, that will be a tipping point. It'll be really hard to go back from there. Right now, our carbon dioxide levels are at 390 parts per million. So we are above that. We've been above that since the 350 organization began, and we've stayed above that. We've actually seen a little bit of an increase since they started.
You know, this gentleman is correct, and I've been at every session for probably the past 15, 20 years. And I know a lot of people, you know, it turns their stomach to walk inside local capital or to really get involved, but it makes all the difference. So instead of becoming a party like the Green Party, becoming a lobbying group to counteract, because it's unbelievable, the oil and gas that's in the Capitol daily, nicest people in the world, the lobbyists, the banking, absolute nicest people, but they're there every single day, and I can't seem to get people with maybe the opposite issue, like the truth, to get to, you know, it's like hold your nose, roll up your sleeves, but go inside the building, talk to these legislators. You know, they are just people who their calling is to be, you know, they couldn't be a movie star, so they're a legislator. And that's not rude, but it's a little bit true. That's their calling, and they need people to back them. And whoever backs them, that keeps them in their calling, they will listen to. But if you don't go inside the building and talk to these people and show up and be a presence, as nice as the oil and gas people are and as friendly and they know the legislators' kids and they want it, that's what we have to do in order to kind of turn it a bit. You know, you can't stand up there and just point your finger and, you know, you got to be personable and do it.
Let me just interrupt. Did you want to change something? Or
No, I was just, okay. So, two responses back to that comments, and then I'll wrap things up. So one is that I can't do this alone. So now I pass it all off to all of you to do this. Because I actually believe one of the best ways to communicate is not through presentations like this, but is to communicate one-on-one with our neighbors, or the person that you're sitting next to in line getting coffee, or your friends at school, okay, those places. I used to say when I was working at the New Mexico Museum of Natural History and Science that I did my best climate change communication on the rail runner. It wasn't at the museum, it was just having conversations one-on-one with people. Because that's really how good communication happens. It's not so much in presentations like this. The other comment that I want to share as well related to your comments is one of the things that I'm grateful for my parents teaching me was that I don't have the right to complain unless I vote. Okay, I lose that right to have a voice and have an opinion unless I actually get out the door and I vote every opportunity that I can. So I hope as you all get older that you'll take that same advice too and vote every chance that you can. Because then you can always have a voice and you can always have an opinion. So thank you. Yes. One final thing I just wanted to quickly, do I have time to quickly describe this activity? Okay. Information on this activity, I'm happy to share it with you if you just come see me after I finish explaining this. So this activity I'm going to present is called What's for Lunch? It's an activity that's geared for middle and high school students. The main thing is that I have a whole pile of food cards here. These different food cards have all different food items, food choices on them. And on the back of each card has a red number. The red number is the grams of carbon dioxide equivalent or grams of greenhouse gases released to produce this different food item. It takes into account all aspects of our food production process, irrigation, fertilization, transportation, cooking of these different food items. It's a good way to kind of get an idea of what your carbon footprint for your food choices look like. One thing I want to emphasize when looking at our food choices is the research is showing that anywhere from 1/5 to 1/3 of the greenhouse gases that are released as the result of the actions of Americans can be linked to our food production system. So if you want to make an impact and a change today, looking at your food choices is the easiest and quickest way to make a really big impact. So thanks. And I'm going to leave these over on this bench over here if anybody wants to take a look at these.
Thank you. Thank you very much.